let's take a little break from the completing the square and just talk a little bit about these different values of k. Sometimes you have problems that ask you, what would the value of k be here to have a completed square? And these are actually kind of an easy problem. We would take our 10, cut it in half to 5, and know that if we squared it, that value of k would have to equal 25. Now that's the way we normally do it, but in this next problem, we don't have a value of k to cut in half, but we do know that when we square it, we get 16. So we can unsquare it backwards to a 4, and technically that can be a plus or a minus 4, but because there's a plus in the line above, we know that this would be a 4, and therefore k would have to equal 8 before we cut it in half. 8 would cut in half to 4, which squares to 16. So that's just another type of problem based upon completing the square. Now let's move on to another problem, but this time it's got a leading coefficient of 2. It's in standard form already. I want to divide off the leading coefficient through the whole problem. Now what I'm going to have is a squared plus 2a. I'm going to leave a blank there, subtract the 5 halves to the other side, and make that minus 5 halves on the right. Now that I don't have a leading coefficient, I can cut the coefficient in front of a in half. 2 will cut in half to a 1, which squares to a 1. Now what I need to do is complete the square on the left, so I'll put my a in, my parentheses, my quantity squared, verify that a plus 1 times a plus 1 is the a squared plus 2a plus 1 that we see on the line above. And on the right side, since I've added 1 to the left, I have to add 1 to the right. Notice I'm writing it in the form 2 over 2 because I want to have a common denominator. And so I will have negative 3 halves on the right. Now we have it in a completed square form. It's ready for us to square root each side. Square root in the left gives us a plus 1. Technically it's in absolute values, but instead I'm going to put a plus or minus on the right hand side, and we're going to have the square root of negative 3 halves. Now we can't have that radical in the denominator, so I'm going to multiply by the square root of 2 over the square root of 2. So we will now have a plus 1 is equal to plus or minus I root 6 over 2. When it comes to subtracting 1 on each side, I'd rather think of this as subtracting 2 over 2 on each side, so that I can write this as a equals negative 2 plus or minus I root 6 all over 2. And again, let me note that this is not in a plus or minus bi form. Technically, if I were to write this in a plus or minus bi form, it would be a equals negative 2 over 2, which is 1, plus or minus the square root of 6 over 2i, so that you can identify a is equal to negative 1 and b is equal to the square root of 6 halves. Now we solve a literal equation for b, and we're going to subtract a squared on each side of the equation. This is going to give us b squared is equal to c squared minus a squared. And you know that we need to square root each side of the equation. So we would have b is equal to plus or minus the square root of c squared minus a squared. Now, we all know that this represents the Pythagorean theorem, and so if you know that there is a geometrical context to the problem, then this really becomes optional. It just depends upon whether we're dealing with a context where b must be positive or not. So be careful in those types of problems. Here we have another literal equation, and I'm going to clear the fractions right off the bat by multiplying through by 3 on each side. On the left, I'm going to have 3v, and on the right, after the 3's cancel, we have pi r squared. Now we can solve for at least r squared by dividing by pi on each side of the equation, and this will leave us 3 capital V over pi is equal to r squared. Then, square rooting each side of the equation, we would have plus or minus 3v over pi inside square roots is equal to r. Now again, we know that r is representing the radius here, because volume equals 1/3 pi r squared that we have up here is a geometry formula, and so I'm going to just say or remind you that this plus or minus would be optional in that sort of context. Now let's do one more completing the square problem here to just make sure we've got it down. We do have a leading coefficient which we want to divide off. So divide by 5 all the way through. 0 divided by 5 is 0. And that gives us x squared minus 3/5 x plus 8/5 is equal to 0. I'll consider that to be the start of my problem here. Now I want to subtract off that 8/5 on each side and leave a blank on the left so that I have something to complete the square with. Now I'm going to cut the coefficient in front of x in half. Now, how do you do that when you don't have an even number? Cutting in half is the same as multiplying by a half. So I'm really going to have minus 3/10 on that next line, which will square to a positive 9 over 100 in that blank. So I need to add 9 over 100 on the right hand side also. Then I'm going to complete the square by putting my x on the left, parentheses around it, quantity squared. On the right hand side, I'd like to have a common denominator of 100, so I'm going to multiply the denominator by 20 and the numerator by 20 to get negative 160 up there. When I subtract in that numerator, I'm going to have negative 151 over 100. Now it's time to square root each side of the equation. This will give us x minus 3/2 is equal to plus or minus, well, the square root of 100 is 10, and we're going to have I square roots of 151 in the numerator, and that 151 is not going to break down. So we can isolate x on the left, keep our common denominator of 10 on the right, bring the negative 3 to the right as a positive 3, and have that as plus or minus I root 151. If you need for this solution set to be written in a plus or minus bi form, then this would be 3/10 plus or minus the square root of 151 over 10 I.